Hello folks. Alright, it has been requested of me to do a video about multimeters, and yeah, we have a few around here. In fact, this might be a collection worthy of EEV blog, because I know Dave collects multimeters too. This is actually one of the original multimeters that we used to use back in the day. It's got the it's made of Melmac. Takes I think a 9-volt battery. You calibrate it with this screw here, and you've got your little gauge right here. So kind of classic. So we'll put this one aside because we're not going to be using it. Just wanted to show it to you. So here are some varying multimeters. This is a ground resistance meter, which is used for testing towers and ground resistance in earth to make sure that you've got a good enough ground, which is actually very critical when it comes to our industry. So this guy here, it's actually, I believe that it's actually kind of part Megger, part multimeter. It's kind of cool. Not a cheap multimeter, by the way. It's actually quite expensive. This guy was like 300 Canadian, maybe 400 Canadian. So, and I don't take it out very often. So we can put these guys aside now. I'll put some aside here. The more common ones that you'll end up using will be like this. This is just a cheapy clamp meter. These clamp meters are handy because you can test, well, on this one, 200 to 600 amps just by literally clamping it over one leg of a circuit. So you typically clamp this onto the hot, and it will measure the electromagnetic field being inducted off of the cabling to actually show you how much current's passing through it. It's actually kind of cool. But this one also, you can connect probes to it and get your continuity, resistance, and your AC and DC. So kind of handy. And then, let's see here. You've also got, this one's a auto range, or an auto set range. This is actually a really sweet meter. It's one of my newer ones. Here's a cheapie from the Electrical Wholesaler. One from Crappy Tire. These two are actually kind of along the same product range. This one's garbage. This just lives in my truck just for the purposes of having an extra multimeter, because these two typically go everywhere with me together. Okay, and then this one, this is my baby. I spent 27 bucks on this on eBay and don't regret it. I got it like 6 years ago. It's got tons of ranges. It can detect logic. You can test transistors on it. It does capacitance. It does the thermal probe. You can actually test frequency on it for calibrating generators or checking line frequency. You've got, let's see here, everything. Just everything. This is a great meter. I've already blown it up once. It does up to 20 amps for current. But yeah, I just simply pulled it apart, resoldered the traces on here, and put on a new fuse. So it's pretty good. So I'm going to try to keep it simple, because, you know, this whole video is just to kind of teach you the very basic fundamentals of multimeters here. Alright. I'll put these guys aside for now. So a couple of things I want to show you first. So what we'll do first, actually, is I got some paperwork for you here. Multimeter safety tips. This is a la Fluke. I actually pulled this from Fluke Network's page, laserlevelhub.net. That's where this image came from, so there's your credit for your work. Thank you very much for the image. I was looking for places to actually get decent, you know, slides for this. So, multimeter safety tips. Choose the right meter. Okay, what they're saying there is that I don't think any of you guys who are watching this video are going to be working on high voltages, but you need one that's got the right category rating for the voltages you're working at. Otherwise, you could kill yourself. It's kind of rare and specific when you actually have meters that are locked to resistance or current or whatnot, right? Check the meter before use. The reason why people say that, and that is very, very important, is that if you've got your meter set up for current, like this, and current uses a shunt type current detector, or a current measurement device, what that is literally like a little piece of metal. And what it does is, as the current flows through it, it'll generate a voltage differential from one leg to the other leg. By measuring, like by knowing and predicting what that voltage will be in millivolts from one leg to the other. You can tell how much current's passing through that little resistor. It's a current resistor, basically. So if you have your meter plugged in like this for current, and you set it to voltage to check the voltage on a battery, you're going to pop the fuse in this, or you're going to burn your leads, or depending on the quality of the meter, basically you could blow a breaker. And if you're dealing with high voltages like 320 plus, it's not going to be pretty, and you could potentially injure yourself or even die. All right, next one. Wear your protective gear. Yes. Okay, so if you're working on high currents like battery banks and whatnot, you do want to make sure that you don't cross any terminals or buses, because that could lead to explosions. And that could potentially kill or harm you in one way or another. Avoid electric shock. This should be a common sense thing. Don't use multimeters wet. Do not use them in the rain. Just practice safety, okay? Like basic electrical safety. Understand the dangers, which is what we're going over right now, and then your CAT ratings. So the CAT ratings, actually, it's got it listed on here, as you can see. CAT 3 is actually rated for up to 600 volts. CAT 2 is rated for 1,000 volts. So when you get these leads, and by the way, if you buy these on Amazon and that, do not trust the CAT rating unless you're buying these from a reputable source. These leads here, these are some cheapies that I got on Amazon because we use them in the lab. We're working with voltages no higher than about maybe 100 volts DC, so that's cool. It says that it's rated for 20 amps and it's CAT 3. So these claim that they're good for up to 600 volts. Again, I do not entirely trust that. All right. Moving on. And by the way, feel free, if you really want, just skip all this intro shit and go straight to the meat. I will potentially put links in the video, no promises, but this is stuff that you should know if you don't know anything about multimeters. And if you don't know anything about multimeters, that's what brought you to this video. Okay, so now these are the common symbols on the multimeter. And let me get something to color them in, because, you know, coloring is fun. Do I have any highlighters? No, but I've got orange marker. All right, so know your symbols. This symbol right here, that's DC, okay, because you've got solid dot that just represents positive and negative. This waveform is a sinusoidal wave, right? That's AC. So when you see that on your meter, like on this one specifically, you see there, you've got the, can you see that? Hold on. Let's bring that up. I should actually, one second, I'm going to bring the camera down. There we go. By the way, I'm working on getting a new camera setup, folks. It's not going to be cheap, but it's going to benefit you guys greatly, and hopefully make my life easier. Alright, so here we go. You should be able to see that now. Can you see that now? Focus. I'm still learning the programs and all that stuff too. So squiggly line, AC. Solid and dot, DC. Okay. So DC is batteries and whatnot. AC is mains. It's coming off line or off a transformer that doesn't have any kind of voltage regulation circuitry on it. MV for millivolts. All right, so that's, well, millivolts. Okay, so we're working with decimal points here. Amps is clearly represented with A. See, there's amps right there. And it's got the DC symbol right next to it. Now, I'm not sure if that's a design flaw on this thing, where they just threw that symbol on there or not, but typically on these particular multimeters, and I'll verify that, the current sensor isn't specific to a type of current. Yeah, that's cool. It actually says DC here. Let's see here. I never considered that. I always thought just amps was amps. Okay. So there we go. We've got volts, AC, millivolts, amps, milliamps, microamps, and resistance. Ohms, kilo ohms, mega ohms, ohm, omega, whatever. The alpha, the omega, whatever. Continuity beeper. So ohms. Ohms is when you're dealing with resistors or resistance. Light bulbs are resistors. Motors can be classed as resistors. Heating elements. You can also use it for continuity. Okay, so that's that. Basic diagrams. And this one actually came from Fluke's website. Fluke.com/fluke/INN/products/digital multimeters.htm. That's just a cool symbol. I'm thinking about getting that as a tattoo on the back of my leg. Yeah. All right. Now let's get on to some practical application. So, first things first, what do we got here? We've got some 22 ohm resistors. If you want to know resistor color codes, chances are you are not going to be using them unless you're into electronics or you're doing building security and whatnot. So, this is 22 ohms here, so this is where these little ranges come in, okay? So, it's going to be less than 200 ohms. Simple. Okay, so for this particular test, I'm going to use a set of crocodile clips. Here we go. And I'm just going to plug them in like so into the appropriate rated ports, and we will just clip these guys on here and see what we get here. Alright, approximately 22 ohms, or 21.4. And of course this is the continuity setting, so you're hearing it beep. Continuity is if you just want to test a wire to see if it's good or not. Right? Let's try testing this. No, there's no continuity there. That's got continuity. This mat actually has a resistance to it. This is a anti-static mat from Sun Microsystems, who no longer exist apparently, and who has been absorbed by Fujitsu. Alright, so there is your resistance. That's basic resistance. I've got another set of resistors here, sorry, let's see. So this is 33. So if I go, look at that, 32.5, so I'm not sure if the calibration's out on that. We'll try a second multimeter just to be safe. Okay, let's try this again. So we'll go 22 ohms, 21.9, 21.8, so this is just out slightly. And of course these resistors are Amazon resistors. Okay, so another awesome setting on these multimeters that's really handy is capacitance. We're going to switch over to this guy for a second here because it does capacitance, okay? So, where's my capacitor setting? Right here. So now I can actually, let's see here, range. There we go. I'm just going to change through this until we get to capacitors. Now, you need to select the appropriate range. So the capacitor I'm going to test with is 3300 microfarad. So I'm going to go to microfarad here. If it lets me go to microfarad. No, it's just automatic at capacitance. So there we go. So there's our capacitance right there. Now before you test capacitors, by the way, make sure that you short the leads together. Because with capacitor testers, if you hook them up to a charged capacitor, chances are you're going to destroy the capacitor tester. Alright, so let's see what we get here. So it's working through, it's auto-adjusting its range. So we've got 3.004 microfarad. There we go. So yeah, it's close to 3300. Now remember, capacitors have a tolerance on them, so they'll be out a little bit, but this is a great way to tell if a capacitor is screwed or not. So yeah, it's within tolerance. That's cool. So there's your capacitor test right there. Now on my other meter, actually, I'll show you an example of this. So this is my big beefy monster meter. Alright, so we will go to, what do we got here? It's 3300 microfarads, so I'm going to go to 200 here.
I actually enjoy this game. I look forward to learning more about
Out of range, let's see.
Is the solo experience much different? I'm just wondering, because I know like when you play Civ...
Out of range.
Like animations.
Why is that?
I'm not expecting it.
Because this is only designed to test starter motor capacitors and whatnot, so no big deal. That's where this meter may actually be the replacement for this one as my bench meter. Okay, so there's your capacitor test. Now I'm going to show you guys some, let's do a current test. So I'm going to turn on my bench power supply here. And we're going to get my dummy load, which I built in a previous video. And we're going to get some pluggy thingies here. Okay, so I'm going to hook up the common first. So we're going to go common to negative. There we go. And let's plug this into 12 volts.
So, can you claim it or anything?
Okay, and I do not think that this is actually running at 12 volts. Just hold on a second here.
Huh. Got my guys to look good. You got your guy, you're all good?
Let's see, we'll switch it over to voltage for a second here. 7.6 volts. So let's just turn this up slightly. One second here.
My goals, I can't look at them yet.
I'm still learning this power supply, so bear with me.
Why don't you grab mine?
Come on.
Really unmarried. Ooh, what? He's married though.
There we
Your
go.
wife.
Oh, hold on. Almost got it. There we go.
My not married. My heir's not married. I hope they're gonna arrange you a marriage somehow.
There we go. Well, good enough anyway. Sorry.
Trust this bro more than I got a girl.
Okay, so what we've got here is we've got this
How can I make her
this dummy load here, and this is basically drawing current. So we can actually look at how much current this thing is actually carrying by switching this to the current setting. Now, here's where it gets cool. So I'm going to put this in line. So I'm going to put this into the common here, and then I'm going to take the red, and I'm simply going to clip it onto here. Whoops. Remember when we were talking about the appropriate ports? That won't work unless you plug it into current. Alright, so it looks like, I'm going to move this around, sorry. In is the red port, out is the common, so we're drawing about 5.4 amps right now. So there's 5.4 amps coming across here. Now watch this, I'll turn off one light at a time, and you'll see the current decrease. Okay, so we just dropped an amp. As you can see, as we go down, the current decreases. Cool, eh? So we're measuring current right now, the amount of current actually going through the circuit. So we're at 5.4 amps right now. That's essentially what the amp setting's good for. So where do you use this? Where do you apply the current meter for this? You would apply it if you've got like a battery or like a switch or a device that you need to find out how many amps it's drawing, or if you suspect something is drawing too much current or not enough current. You can use this to verify if it's operating properly, you know. If it's outside of the range expected, then you know there's problems with it, and you may potentially, you know, have a bad fuse or a damaged device or something along those lines. If that's the case, there, this just helped you troubleshoot it. Okay, so now we've gone through, let's see here, resistance, capacitance, current. The next one we should probably go to is we should show you guys how to test a battery, because that is going to be another important ability you need when you're working on stuff like your tower equipment or UPSs or whatever. UPSs will probably be more likely, or battery banks on rectifiers. So let me just see here. And by the way, I'm hoping to get the audio solutions sorted out sooner than later, so that you guys aren't always hearing my husband here yip-yapping on his video games, because we do share an office. Alright, battery. Where's the battery? Here's the battery. This is a 12 volt, 7 amp hour cell. And by the way, current can be a great way to test and see if there's a battery that's good. You can put it in line with a charger. I'll show you that in a minute too, actually. I want to be thorough here, but I don't want to be too long or too boring, because I don't want you guys to lose interest. So let's show you how to test a 12 volt battery now. So I'm setting this for voltage. Remember, we were just testing current, right? If I had the leads plugged into this and then I went to go test this, it would pop the fuse in the meter. Okay, so we're going to put the negative in common, and I'm going to clip it onto this battery. And damn it, I think I need a drink. We'll clip the positive on here, and now let's check the voltage on this battery. 12.83 volts. That is great. So that means that this cell is in decent shape right now. Okay, so what I'm going to do is I'm going to drain the cell for a second, and then we're going to use the, I'm going to get a battery charger, and I'll show you how to test the current on a cell, okay? I'll show you a good cell versus a bad cell. So 12.8 volts, that's a great voltage for this, because look, this is your battery sizing chart. Where did I get this? This was just off the, battery charge state for AGM. This is an AGM SLA, so sealed lead acid, but it's absorbed glass mat. See, not draining. So, Charge state at 12.7 plus for sealed lead acid or sealed or flooded lead acid batteries is 12.7 plus. That means it's at 100%. AGM batteries, full charge is 12.80 plus, and gel batteries is 12.85. We are specifically going to focus on the AGM because that's what most of your batteries are going to be in your tower assemblies, okay? All right. So now that we've established that, I don't think I've got anything I can lay across here like a ruler. So full charge is 12.8. As you can see, this battery is full. Do not store these things flat because they'll just destroy the plates. They'll sulfate. 12.6 is 75%. 12.3 is 50%. 12 is 25%. And 11.8 is a dead battery. Now, I'm using 12 volts as an example because when you're working on your systems, the common voltages that you're going to find at your plants are going to be 24 and 48 volts. So using 12 volts as a baseline is great because with a 48 volt system, you just multiply 12 by 4. So you can use these numbers as your just an easy reference. So 25% charge is 12 volts. So if your battery bank in a 48 volt system is 48 volts on the dot, that means that it is dead. That's like 25%. If you're up at like, just off the top of my head, I think 57 volts, that means that your bank is fully charged, okay? That's how that works. And that's why you'll see on a lot of devices like a PowerBox Pro or a Hex PoE or those things, 57 volts that they'll operate up to, because that's the full swing of a battery's charge state. That's what you're going to see here. All right, so yeah, let's kill this for a second. I'm going to... Oop. Sparky. I'm going to hook up my dummy load for a minute. And we're going to run this down. I'm just going to grab a battery charger quickly. Hang tight for a second. Okay, so now I'm going to show you how to check a battery to see if it's any good. I learned this when I was just a wet-nosed pup. So first of all, listen closely. That is not water. This cell is out of an APC UPS. It is dried right out. It is done. If you want to verify that, let's use our multimeter. Put that under here for a minute. I'm going to burn myself on those light bulbs, by the way. You watch. And if I do, then, yay, that's funny. I injured myself. Okay. So let's go over here for a second. I'm going to plug in my multimeter and set it for voltage. And if you check this, 2.3 volts. That is a dead battery. What's our charge state right now with this thing draining at 5 amps? We're at 11.7 under load. So that's fine. That's because it's under load, so it's dragging the voltage down on the battery bank to compensate, okay? Those light bulbs are getting hot. Alright, so now what I'm going to do is I've got this really handy dumb power supply. Regulated 13.8 volts DC, 4 amp power supply, and this thing can friggin' get hot. The reason why I'm picking such a dumb power supply is because, well, there's no charge circuitry. This is literally just to run CBs or bench devices, so I've got this here specifically for testing equipment when I'm working on DC systems. Kind of handy. So now I'm going to plug this bad boy in. We'll put it right over here. Let me get down to a plug here. Oh, my fat. What can I unplug? I can unplug this. Alright, so let's do this now. I'm going to unplug the batteries because clearly I have taken the charge down just a wee bit. Oh, it's getting warm. Alright, so here's how we test our batteries. First of all, remember, positive is red, negative is black. Okay? So if I plug this in here, I'm going to hook up the common first.
Sorry, go ahead.
Now, we want to measure this in 2 ways, potentially. I'm going to grab a second multimeter. I'm going to grab Old Faithful here, and I'm going to set it for 20 volts DC, because 20 volts is higher than the voltage that we're working with right now, okay? So just stick that right there. And what I'm going to do, actually, is I'm going to plug my... Here we go. This will give us our voltage here. So I'm going to plug these leads in like so.
Oh, wow.
You're going to see now why we have pass-through banana connectors. So we got 14.5, so that's full charge state on a float on a system. Okay, so now, if I plug this positive into here, it's going to draw the current down, or draw the voltage down, because it's actually drawing current now. Now watch this. Okay, so the out is the common. And I need to grab another set of bananas.
I don't know which town he fucking owns.
Where are my bananas? I need to order more of these things, by the way, because I gave a whole bunch to my technician. Alright, so we'll go just red. Stick that in like so. Oh, wait a second. No, do I need to? Yeah, I need to do that. Okay, so you can see that this is current. This is the voltage. So now, here's how you tell if a battery's good. If you see the current go up when you hook the battery in, it means that it's actually pulling. Oh, hold on. It means that it's actually pulling a charge, so it's charging itself. So this battery here is drawing 4 amps right now. This is charging, okay? So, you see that the voltage didn't drop much this time? That's because this battery actually took what charge it needed like a minute ago. So, right now the battery is actually charging 3, it's pulling 3 amps, and you're going to see the current decrease as the battery reaches equilibrium with the charge source. So as the voltage differential decreases between the battery and the charging source, it's going to draw less current. Okay, so you're seeing the current drop right now because the battery doesn't need as much. It's coming up. Electricity, like everything else, wants to find a zero state. It flows like water is the easiest way to think of it. Water flows downhill, it goes to the lowest point. That's just typically the nature of things. That's physics. That's how we understand things right now. Okay, so now we know this is a good battery. We know that it's charging. All right, so now let's try this other battery here, which we know is fucked. All right, so let's plug this one on. I'm going to red on here and black on there. Would you look at that? It is drawing no current. Nothing. So we know that because I just connected this thing, that it's dead. And if I unplug it from the battery, or the charging source, you'll see here, we've got 3 volts. See how it's dropping really fast? It can't maintain a charge. So if this battery was completely flat, but it was in good condition, you would see the current jump as high as this charger can actually provide. It would draw as much current as it can suck out of this thing. But because the battery is actually dead, it's damaged, the plates are no good, they're all dried out. When I plug this in, you can see that the voltage jumps immediately. It doesn't get drawn down, and it's drawing no current. There's no load from this battery onto that charge source. So now we know that this battery is kaput. Another dead giveaway, by the way, that a battery is no good is...
It's not called a trifold information, it's called Fuhrman's triad.
Yeah. So... this usually happens. Okay, we're done with the meters for now. But I'm going to go back to the explanation about batteries here, because this is ultimately where you're going to be using your multimeter the most, is on checking your UPS batteries or your DC plant batteries, okay? So let's put all these guys over here. Should I start wearing a sweater? Like, should I do like a mock Mr. Rogers thing? Would that be cool? I don't know. It's not like you can really see me except for my heaving gut. There we go. Alright, so we're done with these guys. Thank you. You've been great. Bye, multimeters. Okay. So if you look on these batteries, they kind of tell you what they need. So we can see here that the cycle use is 14.4 to 15 volts. That means that if you stick it in a system, it can operate at those charges. That's overflow. Now, if this is a standby use, you want to keep it at a float charge. So that it doesn't overcharge it doesn't run the plates and create hydrogen sulfide gas. If it does that, then if they gas, you're losing your moisture, and if you lose your moisture, your battery dries out and it is toast. So right here you can see 13.5 to 13.8. Personally, I like to stay at the low side of float, because as long as it's over 12.8, ultimately, while it's in an idle state, the batteries will stay healthy until they're needed. But running them at 13.5, 13.6 on an AGM is perfectly fine. It's a great way to keep your batteries maintained. If you run them at 14 volts, or higher than 13.8, this happens in a short period of time. So, a little tip for you. APC UPSs typically run at higher than 13.5 volts on standby. They'll actually run at 14.2, which is stupid. You can do that with flooded lead-acid batteries, but AGMs dry out. So you can actually change the voltage set point on those UPSs if you hack into the firmware. On older ones, you can plug into the serial port and do it, and you can actually hook up like a 1500 watt or whatever halogen light to recalibrate the units, but that's another video for another day, and I don't really want to do that because you really only have to do that with APCs. Most of them come well tuned. But that's the gist of it. That's really what you guys were wondering was, what is a multimeter? How does it work? What do I need to know? So I think I've covered all the grounds that you guys need to know, except for one little bonus point here. I'm going to take these guys and put them aside.
I went to check it out on this half date, note that it might be a detailer. I was like, alright, let's see what happens.
I'm going to get this one out because I really like this one. This is great for somebody who doesn't understand multimeters as much because it does everything for you. So we're going to put this aside, and now what I'm going to do is I'm going to get an electrical cord here. Don't try this at home, folks, because chances are you're going to get electrocuted. Especially if you're in a country where your mains voltage is like 220. Okay, so what we're going to do here is I'm going to show you how to measure your line frequency. So I'm in Canada, so we're working with North American current up here. It's typically 60 hertz, unless you're running on the DC lines, which no civilians typically do that. So I'm going to set this for frequency, hertz. Now I'm going to stick this in the ground here, and then I'm going to take the other one and I'm going to stick it in line. Actually, isn't that interesting? Do you see that? As soon as I plug it into earth, oh, that was probably an anomaly. Or wait a second, yeah, that was a strange anomaly. Okay, so if I plug this into line now, look at that, 60 hertz, bang on. You can also test it if there's no ground available, which doesn't happen very often. You can also plug it into the neutral, and you should get the same reading. I use ground because that's just a really solid reference point, typically. So there, we know that we've got 60 hertz with intolerance here, plus minus 1%. Where this is really handy as well is if you've got a site where you're having problems with the UPSs or you're running a generator. You can verify that the generator is actually synced appropriately by using your multimeter. Because if your generator has an issue, one of the most common ones is that the idle state on the generator, its actual RPM, is out slightly. It'll actually phase out, so you can get like 57, 56 hertz or 65, 66 hertz. And if that's the case, you simply have to adjust the governor on it with the probes plugged into your phase. I like going across both of them on the 220 side of things rather than half going to 120. And then you can adjust the cycle, the duty state of your governor while you're looking at this and get the frequency back to where it belongs. So I think I've covered all grounds. If there's anything I'm missing in this video, just let me know in the comments below, and I will address it. And heck, if I missed enough important stuff for you guys, I can simply just make a new video. But there you go. We have just talked about multimeters, and I think I've covered everything that you guys really need to know. So yeah, on our outro right here, let's put very, very nice multimeter right here, and we'll go down to the cheap but awesome crappy Canadian Tire jobby. Really sweet $40 jobby on Amazon. And commercial electric, which is just cheapy for household because it's actually got household battery voltages on it. And where's the last but not least item? Last but not least, clamp meter. Clamp meter, handy. Remember, if you're using the clamp meter to check the amount of current that's on a circuit, what you do is you can crack a panel if you're an electrician, or if you know your safety. I don't recommend this. And you can actually set it for current and then simply clip it around one of the blacks, and it will show you how much current's on that circuit. So yeah, I think that is pretty much all you guys need to know. So thank you. Remember, if I missed anything, let me know in the comments below. If you guys want me to cover a specific topic, like whatever, yeah, leave that in the comments below, and I'm always open to suggestions and whatnot. So, I have so many multimeters, and I love them all. All right, you guys have a great night. Happy Saturday. See ya.